Hi, I'm Olivia Albers, and today I'm going to talk about the effects of fatigue on motor unit recruitment using electromyography, or EMG. EMG detects action potentials of motor units in muscles. Current literature says that fatigue will create an increase in the amplitude of EMG data. This is due to the increased motor unit recruitment of a muscle as it tries to sustain a constant load. The purpose of this study was to explore this idea in isometric contractions of the wrist extensors and flexors using a hand grip dynamometer and EMG electrodes to collect muscle activation data. Subjects were taken from the Regis University 2019 DPT Biomechanics class. Exclusion criteria included recent arm or wrist injuries that could prevent them from properly performing the test, or latex allergies or skin sensitivities that could cause a reaction to the surface electrodes used. Electrodes were placed on the muscle belly of each subject's wrist extensors and flexors, and a maximal voluntary contraction was taken. 25% of this force was calculated and then sustained by each subject for the fatigue test. EMG readings were taken every 30 seconds for up to 300 seconds and converted to a percent standard of each subject's maximal voluntary contraction. The averages of this data can be seen in the graphs, where trend lines for muscle activation have a negative slope, but there is not an increase in amplitude. This does not support the hypothesis or currently accepted muscle fatigue EMG data. The results could be due to errors in electrode placement, as well as data recording. But literature also introduces the idea of smaller motor units of slow-twitch muscle fibers having smaller amplitudes as an explanation. When larger motor units of more fatigable muscles drop out, a decreased amplitude would be expected. Clinically, this thinking can be applied to a more deconditioned population. It is important to understand when larger muscles fatigue and drop out, decreasing a patient's strength and stability, making them more susceptible to injuries or falls.